introduce Amir Abrari. He's an Innoslate systems engineer at SPEC Innovations. He holds a bachelor's and master's from George Mason University in systems engineering operations research. He's been involved in many projects, particularly very involved with our LLM APIs and artificial intelligence integration into the Innoslate platform. He's also been working a lot on System LV2 and many other projects. So, Amir.
All right, thank you, Steve. So good. I guess we're still in the morning. Morning, everyone. So today I'll be going over the test case, AI, and a little bit more just general AI features that we have available on Innoslate. For starters, we have about 8 AI features currently deployed on platform, and we plan on, yeah, I got you. I plan on going over those. Yeah, sorry about that. Going over those and discussing those at mass, and then I want to have questions on how that works on the back end. So if there's questions on that, I can obviously address that. So a little bit about me. I know Steve mentioned it. Innoslate system engineer really helps me have a lot of information about what we're doing, what we're planning to do, what we've done with the implementation of the software. It's given me a lot of knowledge of the software end of things, and I've really come to appreciate it because it kind of gives light to what we're capable of doing, what we could do, what we can do, what we can't do. All those things kind of have enhanced what I've been able to do as a consequence, I guess, positive consequence. And a little bit on that front, LLM was a big focus of what I've been doing. A lot of the AI features, for sure, all the AI features that have come in have just been kind of a group vision of what we want to do. And you'll see that we started with a lot of low-hanging fruit, a lot of stuff that, not requirements yet, because everybody talks about requirements yet, right? And that's something that we're obviously developing, but some other stuff like doing risks, generating risks automatically, generating test cases automatically. And obviously we have the goal of implementing AI where it's feasible and it's capable of. So a little bit about Innoslate, all-in-one tool, fully US-owned product that it aims to be an MBSE tool that covers all of what you need for system engineering and product program management. I know we've talked about Innoslate a bunch, and we're going to talk about it later presentations, but kind of notable things: AWS Cloud, Gov Cloud, and enterprise versions are available. A lot of different certifications, such as being on DoD STIG, being CAP card enabled, being centralized on Iron Bank, NIPRNet, CIPRNet, all those things. So whatever security concerns you have should be pretty taken care of on that. And if there's other ones, please just let us know. And notable customers are over there: Bechtel, Customs Control, U.S. Navy, MITRE, both. We serve domestic and international customers. It's important to tell, but it's important. One of the natures of what we can do is just kind of pushing updates out, which has really helped me on the AI stuff. Is put our hooks together, and the API hooks for OpenAI especially, they're very flexible, give us a lot of flexibility on that end. Before we get into it, VNB, system engineers must know about VNB and what it is. An approach that we believe in is doing the system engineering part, which is developing your requirements, but simultaneously being able to generate your test cases with some level of expertise and verification, and kind of simulating that process. And automating that process is a big goal of ours. The V model goes left to right and it kind of monitors that way. And then the goal is to kind of make that process easier, but have the human in the loop. Every AI feature we will implement, and we have implemented, all the AI features will always have human in the loop. That is kind of a standard, and that is a belief that I have as the Innoslate system engineer, and that is what we're going to make sure to have. It's verification steps in every step of the AI generation, because that's what you need to have. That refinement, that prompting, that's something that we give a lot of control over because it's important. So just a general way of how we've been doing test cases, testing, verification, validation. Every test case, it requires a test description, expected result, actual result, status, and status roll-up. Now, these are some of the key metadata features that we provide to the AI. And in the prompt message, we have generate test cases based on these rules. You have your persona. Obviously, we've talked about persona. Mantic has done a very good job at describing what a persona is, which kind of gives me the advantage of you guys already know what personas are, right? And that persona plays a huge role for us because with that persona, we also have an embedded message that has give me my test description, expected result, status, and all those things we can go ahead and integrate on platform on Innoslate without having to then go on another tool and sync it that way. So that advantage has played a huge role for us. We can kind of generate requirements, test cases in parallel, generate the test cases automatically, create the traceability automatically. So some of those advantages that we wanted to play at in general. So overview of all the AI features. We have about eight AI features and 4 NLP features. So that rounds about 12 just AI and ML. And that list will keep growing. I don't want to get in too much trouble by saying stuff, but we have a lot more coming. I can say we have at least 3 to 4 coming at minimum. I'll try to push in as many as I can. That is feasible, and that is feasible with our feature cycles. But requirements AI, I can definitely say this. So a little bit more about it. Each of our features show up in different ways. Now, the more button is what you're going to be looking at mostly. If you're looking at the top level artifact, generate test cases, generate risk, summarize, and translate are some of the custom routines. If you're clicking an entity, generate risk, generate test case after, and splitter, it's going to be an option. When you're in the rich text editor, which is the redactor, you're going to have other AI tools. So the reason I show this on the top right is because AI can show itself in different ways and different methods, also in different points. And again, this is only going to, expand more. We're going to have a requirements button at some point that is going to come there and be like, generate your requirement map. So we're going to have a lot more that's going to be coming, and we're trying to make sure it's centralized and the buttonology makes sense because we're a modern tool and we're trying to make sure we stay on par with kind of the agenda of being easy to use. Things are, where you expect it to be. And if they're not, the feedback is what we're looking for, and let us know. So test case AI, again, I'm going over this particularly into the presentation, but I'm going to go through the demonstration and just show all the features. As I mentioned, this is what the metadata projects. So we trained the model through prompting to give me my number and name, auto-generate that, but you have a structure for a number that you should follow. Give me my test description and mitigation strategy. The mitigation strategy being explain how to mitigate this in Word, right? And we implement that. My expected result, based on the context that you're given and what you generated, what do you expect to happen? For example, the system should respond at 150 milliseconds, for example. That's one example of an expected result. And we've had the capability to be able to be like, give me my verification method, whether it's test, inspection, modeling, simulation, all those things. And because in our workflow, we have a targeting system, target what requirement you want to get context from and build a generate a test for. We can just automatically trace it using a verified by relationship. And that is a constant with risk AI, which is causes, and it will be the constant with all the other features because we want to make sure we automate that traceability as fast and as feasible as we can. And with that, once you generate your test cases, the VMV gets even easier. Generate reports as you want, kind of test case reports, CSV reports, document reports, whatever helps you communicate with your stakeholder best. And that's the conversation we were just having on being able to communicate with your stakeholders better. But that is the whole goal, right? It is, I want AI to help me generate my test cases. I want to verify what the AI is generating just so the test cases are good. Once we do that, I'm going to compile my test case, do my testing, whether it's passing, failing, kind of maybe even do my test cycles with my baselines, how many test cycles it takes for a product cycle, and then generate the report if you want. And that report's going to be very helpful with communicating with your stakeholder on that front. And that's the goal. And because we are already doing your automated traceability, so if you choose a requirement, which I will show, and generate your test case automatically, that automatically compiles it in a traceability matrix. That will allow us to be able to pull a traceability matrix and go ahead and be like, hey, what are the requirements I have to my test cases that I've already generated? It shows it in the X. And then we also provide NLP tools that say, use a suspect assist to view existing relationships and be like, look at them and say, do you suspect that there shouldn't be a relationship between these two items? and that is done through regex NLP analysis of comparing the number, name, description, and seeing commonalities or violations, right? And the traceability assist in green, respectively, recommends relationships that should be added. And the strength of probabilistic data is 33%, 66%, and 100%. We can obviously expand that as we want. But the brighter the color, the darker the color, I guess, the higher the probability that our model expects there to be a relationship. So it's an inverse. Red means that there shouldn't be. Green means that there probably should be. If you don't want the assist, you can just remove it. And that's something that we can always do. So yeah, that's a little bit of background on how you can do verification and validation on that end. Now, I'm going to go over this extensively. AI security is very important. We provide up to 3 providers currently: OpenAI, Azure OpenAI, and Ask Sage. This means if you have an Azure OpenAI environment already, that's Azure Government. If you've gone through those protocols and gotten, IL5 models, you can plug that IL5 model into Innoslate by just your API key. You don't have to go through any other interface or do all that stuff. Now, if you want to use a public OpenAI, you can do that. It's very easy to get. But this is the general screen you get. Ask Sage also, it's a subscription-based item that is also IL5 that allows you to reroute your model, but still generate information. So what's important in this piece is that only admins can do this. We on the cloud provide ChatGPT 4.0 mini for free. So all the AI features are available for all paid users for free. But if you want to use government models, if you want to use your own models, if you want to use O1, for example, for some of our free features, we don't provide that for free, obviously for costing. But if you want to use it, you can go ahead and put your own API key, cover your own cost, and put it in there and use it. So we provide some defaults, but there's obviously a lot of flexibility. And I'm actually going to start the demonstration piece of this in this screen just to go ahead and show it. So we use 4.0 mini. We will be moving to 4.1 since it was released last week after some testing and making sure that we comply. So a little bit, I'm just going to go ahead and get into I'm just going to go ahead and get into the presentation piece of this. So initially, I just want to go ahead and show the admin panel and show the capability to go ahead and enable our chat models. And you see in this example, I have my provider set as OpenAI, but I can obviously go ahead and switch between Ask Sage, Azure. Once you do that, this base URL is obviously auto-populated because that's the base URL that it follows, but API key, secondary key, and once you go ahead and search this button, all your models are going to be used. So I can use 3.5, which, why would you? But you can use all the models, the nanos, the 4.0 minis, 01, 03, even 04 that came out literally last week. But that's on OpenAI. Now, if you go to Azure, if you go to Ask Sage, you can use Gemini, and all those different things. It's a preference thing. You have control, and that was what we wanted to do with this. Now, you can also set token limits as the admin. So if you want to say, I want my administration and organization to have 30,000 tokens per day, you do that, and that kind of gives you more constraint and control over your production. Now, all the image features that we have a separate hook, have a separate capability set. That's by design because images are much more expensive than chat models. So we give that liability cost and leave that liability cost up to the customer, not up to us. So I just want to disclaim that that is by design. So just getting into just showing off some of the capabilities that we're able to do on there. This is a test case document. A test case document usually, it can look in many different ways. There's a lot of functionality there as we would expect, but to use the test, AI features, as I mentioned, they're going to be all populated in the more section. When you click the more section, you have 2 options in this test case to generate a test case after what you're using. So usually our AI features are going to have this pop-up initial screen where it asks you, what do you want to target? What do you want to generate for? I want to generate a test case for charging compatibility. Cool. Now, this charging compatibility has a child, which is the focused entity, has this requirement, shall interface with both AC DC fast chargers. It will also query the parent entity if there is a parent entity. Why? We wanted to go one level up for any requirement and give more context if there is. In this case, you see it's empty. It's an empty string because there was no additional information. You can always delete it if you'd like, or you can provide more information. I can say range and live demo is 150 to 250 kilowatt, right? It will take this extra information and incorporate it in your test case. So once you're happy with what you have, you just click next. It goes ahead and generates your test case for you automatically. Now, it's very important because this is a preview. It's a verification step. So every single AI feature will have this feature. Now, connect at 150. It took my 250 kilowatt there and incorporated that in the test step. But you see here, 1, 2, 3, 4, 5. If I don't like this fifth step, I go ahead and do the human in the loop part of things. That is the most important part that we're always going to have. Every feature we will add will have a verification step because I'm not going to let AI do all of it. I have to have a step in there. Your expected result is also incorporating the 250 that I added as context. So as expected, it gives you your number, name, description, and expected result, and decides on your verification method, which in this case was demonstration. We've done a lot of testing. It's not just going to stick to one specific verification method, but again, you are at the consequence of decision-making of AI. So whatever it decides, that's going to be there. But again, that's why the human in the loop is, where if you see this test case and say, oh, I actually think this is the verification method for this should be testing, you can just toggle and then create. Once you do, it'll auto-populate your document, hence making this process very easy. So you can imagine if you have a massive requirements document, instead of manually putting this one by one, you can auto-generate a lot of test cases and really optimize your process that way. Currently, test cases can only be created off of requirements or subclasses off of requirements because that's kind of the general workflow we're aiming for. But you can generate risks off of anything: cost, schedule, time, actions, anything can generate a risk. So I'm just going to move into that next. So I just generated a test case, and I want to see what risks come with a test case that I just generated, right? I'm going to go to more again and generate a risk for this. As I mentioned, it will go ahead and query all the information from that test case. There's no limit here. There can be as much information as you want or as few as you'd like. Again, the same workflow works just to make sure that you are keeping this as easy to use. But I just queried the test case that I generated. I click next. It'll generate 5 risks for me. Let's look at some. Charging protocol failure makes sense. Incompatibility with fast chargers, that's important because the plugs, one might be a different plug, and overcurrent protection. So we currently allow up to 3. I'm probably going to make an adjustment and let all 5. We'll see. But basically, you select which ones you want to generate for. You can deselect, do all that. And if you want to generate all 5 of them, you generate this one more time. We have a step in the AI that does make sure there's no duplicates. So if there's duplication, we have our AI check the relationships tab before it generates, so it doesn't generate any duplicates. Again, similar to the test case AI, the risk AI is capable of giving you a verification step. This is the first risk, the second risk, and the third risk, right? And it goes ahead and generates your number, name, description. That includes the description of the risk plus the mitigation strategy. To mitigate this risk, you should do this. Your consequence description, which describes why it shows a 70% on the consequence number. Your probability and the type of risk, cost, schedule, performance. Steve wants us to expand on technical, so we will. But technical being the performance risks. So we can go ahead and actually expand on this label if you want. And it gives us flexibility there. So you see these percentages, they play a huge role into this because on our risk diagram, I'm actually just going to go ahead and see again, you verify what you want. If I don't want to mitigate this risk, that's fine. I can get rid of it. There's no, that's human in the loop is very important to us. And you go and create it. Now, because I'm not in the risk diagram, it's just going to populate my database for me and I can go ahead and allocate it at a later time. But just do a very quick example. If you're in the risk diagram, which is a very powerful diagram, I actually have an example, but let's just start new. Why not? If you're in the risk diagram, which is a diagram that allows you to put your risk in a risk matrix, right? And there's a generate risk button, same exact structure. But once you click the generate risks, you choose what test you want or what, to do overhead cost. I think I have one here. Because cost, we can obviously do cost. Well, this is more attributable. That's why I want to include attributes here. Yeah, it's, any requirement that has, I guess these are empty ones. That's fine. I mean, quotes are, if you have. Okay. Yeah. Like this data transmission protocol requirement, right? Again, we can query it if we want. We are happy with what context we're given the AI. We click next. It auto generates our risks for me. I'm gonna do 2 to go faster with the process. But the goal is to show that then we can actually go in and append this risk in the risk diagram. So you can make a risk diagram that has 20 risks in a matter of 3 minutes, maybe post verification 10 minutes. But this allows you to generate a lot of information. It'll automatically place your risk using the consequent of probability. And as I mentioned, we'll create your relationship for you. So this risk is being caused by a data transmission protocol. So okay. So a little bit more about, 5 minutes. Some more capabilities that we have. We have in the more section of a document, you can go ahead and summarize your entire document. So it pulls the hierarchy of your entire document. You get to choose which hierarchy you want to include or exclude as a part of the summary information. It generates, again, key notes of the summary before it gives you a chance to, validate. You can choose if you want 1, 2, or 3 paragraphs in what language. These for 17 languages in that sense. And once you click next, it'll generate the summary for you. It'll, again, give you a verification before it populates. And once you're happy with it, you click update and it'll embed that into your document for you. Again, we have a 4.1 model coming, which makes it 60% faster. But we're only going to make this process faster for you. If I refresh, I actually have an example. I don't have much time, so I'm not going to wait for it. But again, this is a summary that we had AI generate for us. Moreover, 2 minutes here. We have capability to go ahead and translate mass documents in a language. I was just talking to Sarah about the fact that she was, translating a document to German. You can go ahead and do that automatically on this, and it'll generate a carbon copy of the document that you're in into a new one for you. Automatically do that way. Some of the in-text features that we have is when you're in a redactor, you have a AI text tools button that will allow you to engage with the text. You can change the tone to sarcastic if you want. Steve loves this one. You can change it into professional, academic if you want. You can also translate each block independently. I just translated this block to German as I wanted. That's a German language. I can't verify if it's right, but again, you can switch this back to English and see how it did. You can simplify it, shorten it. Again, if you have a massive document, you can do that. You can go ahead and use a splitter tool to split this 3-paragraph. You can split by paragraph and have them be siblings. You can split that massive text into 3 different data points. And that splitter will allow you to actually split these to independent ones. We have AI image ones that'll actually generate an AI image for you using DALL-E 3. It'll pull the information and generate the information for you. I'll be very interested to see what this actually generates. Give me a minute, Steve. I don't know what this will generate. I have no idea. But why not, right? And again, from the image it generates, we'll know what this means, I guess. But again, these models will only get faster, and the pace within will only get better over time. We're already seeing a massive improvement. So I'm assuming this was a battery management system requirement, and you can just insert that in there. Boom, we have figures. Finally, I did want to go over the AI prompter. This is a massive feature that allows you to kind of highlight what I want, go to my plus button in my AI text tools, and use a prompter. right? So I want to query my requirement at the top, and then I can say derive 5 requirements for this. I can do it again in sarcastic if I want, which would be very interesting. Sarcastic requirements, right? But the point is, you can do anything with this, where it takes your data and generates information for you. Now you use this information to put elsewhere. Now, on the requirements end of things, we'll have an AI tool that does that and embeds that automatically upcoming. But this is limitless, where I can generate an SRD spec or a rationale or anything in that sense. Lastly, we have, yeah, we have an AI assistant that goes over, it's just, we have an AI assistant that is basically an OpenAI chatbot. What day is today? It'll tell you what day today is. And we have a help bot that, what is an action diagram, or how does a relationship work, like a trace to relationship work on Innoslate? That'll give you that help bot. That's an embedding CSV that we have. So sorry, I went 2 minutes over, but.
Well, you know, then leave any time for questions. Are there questions? All right, lots of questions. How about can we defer those afterwards? Because we really should give a break time between. So.
We'll jump in the hallway after.
Yeah, exactly. Yeah.
That's fine. Thank you.
Looks like a very bionic tool to me.
We think so.
Bionic framework and build it into the system.
Yep,
You have to figure.
we can talk about that. We should definitely talk about that.
That's the thought.
Okay, let's see. I gotta find the file. While we're doing this, we're waiting for this thing. I've got to see if I can move something quickly. Presentations. Come on, junk. Can't do 2 at a time? Okay. Okay. 2 minutes. What's going on? Why did that not, it's not gonna work. Some reason I've lost. Okay, so now I'm gonna have to put that up. Wait, that's it. There we go. All right. Okay, getting a little nervous here. So we are firm believers in cybersecurity. So, but to I think it's here. Okay, I'm going to be presenting on a new thing that we're looking at and we've been working on. So let me get this going here. For some reason the PowerPoint didn't give me everything it's supposed to. I think most of you guys know me at this point. So Steve Dam, SPEC Innovations. I'm now putting my hat on as a member of the LML steering committee. So for some time, as we've talked, LML is a semantic language. Okay, we have nouns, we have verbs, we have adjectives, and we have adverbs, right? And everybody knows that mapping. Pretty comfortable with that idea? Okay. So we had this thing about sequencing. How do we describe the sequencing that goes on in like the action diagram or the types of diagrams you might use, like a sequence diagram or state transition or things like that? And so we wanted to keep again with the basic English language and say, well, what language elements help us understand sequencing? And one of them is conjunctions. And it seemed to be a really good one because it matched a lot of the verbs and words we were already using. So that's what I'm going to be talking about today. So, again, how many of you remember conjunctions from English? Okay, yeah, because your English was fairly new to you. But most of us, it was like something we forgot like minus infinity ago. And certainly last time I studied English was certainly a long, long time ago. So I think it's important to go back to these definitions and looking at it and see if it's really what we want. And when you look at it, particularly that second definition there, the action or an instance of two or more events or things occurring at the same point in time or space. That's a pretty good, the word action is exactly what we talk about, right? They're actions in a diagram. So for an action diagram, that's what we're sequencing, is that, and then talking about them occurring at a point in time or space. So that's kind of interesting thought with it. So that's why we thought that was a good place to start. So what we wanted to do, our goal is to how do we describe an action diagram in text? Now, why would we want to do that, right? You're going, it's a diagram. Why would we want text? Well, the purpose of the text is to have, again, a way to describe it that you can move the information more easily and understand it more easily. Plus, it makes it more exacting in the specification of the diagram itself. So again, that's the kind of thing I think we're looking for to make it more formalized, the language. And so that's why we're heading in this direction. So we're starting with one of the hardest diagrams actually to do, which is the action diagram, but it is our main diagram in LML. So for behavior and for sequencing, and in fact, it's the only diagram we use for sequencing in LML specifically. So that's where we are. So that's why we're going to do this, and I'll show you where we are today with it. And in fact, is this news to you totally, Warren, by the way? I've been kind of working on this on my own, so I don't know how much you've been tracking this. So Warren's the chair of the committee, so I'm presenting to my chair for the first time, by the way. Yeah, what's this about? Okay. Steve's wild idea. Okay, so again, you look at the kinds of sequencing we do in an action diagram. So the top right is the simple sequence, right? Action 1 to action 2 follows action 2. And what that means is action 1 has to complete before action 2 can even start, right? That's what a sequence means. If I look at the or, which is on the far left here, that has two possibilities, right? The or there could go one path or the other path, the yes path or the no path. And so either action 2 or action 3 will get executed, but not both, okay? So it's an exclusive or.
Similarly, the next one, we're seeing 3 options rather than just the 2. So a lot of people get confused that sometimes they see that. And so, in fact, I watch people do this. How do I add an extra branch or an extra thing to it? And yes, you can. And the tool the Innoslate lets you do that. But it has been part of the basic language from day one. So I wanted to make sure that was explicitly there. And then to the right, but in between the 2 diagrams, there's the loop example. So now we have a loop decision point, okay? Now that decides whether I continue and execute this 1.2 actions and loop it, which then will loop back for that another decision to determine whether to continue or to exit, right? So again, I wanted to be able to describe that. And the last, but probably the one that confuses most people is the sync. Most people aren't used to parallel. How many of you have done parallel process computing? Okay, okay, in software development. So you always have a synchronization step when you've got 2 parallel processes, you need to sync them back together. So I could have multiple cores on my computer running and different pieces of a problem, and I want to bring them back together. That's the idea of the sync. And that's the general thing. And so only one specified in LML. In Innoslate, we have an example of that where we don't have the sync in there. It looks like just a parallel. And what the parallels do then is that means that both actions have to complete before you can move forward. With a sync, that's actually a decision point to determine, well, maybe at a certain time, I want to exit this construct, this action. And a good example I use oftentimes is I've got 2 squads in my platoon, right? And I send off squad A and squad B, and we're going to rally at a certain point in time. And if the both of them don't make it at that time, I've got to move forward with whoever's with me and have maybe a waypoint later that we meet up again. And so these are the things that as you're modeling, you want to be able to do is have those decision points to be able to move on. So sometimes it's called a timeout. So it's been generally that's a decision point. You can put any decision logic in there you want. Okay. Again, going through the simple sequence. So now let's figure out how can we use these conjunctions to do that. So again, there's a long list of what are conjunctions, and I didn't want to take too much time doing that part of it. So if you want to talk about that afterwards, I can certainly do that. So the idea, what we said is, well, in English, action 1 occurs before action 2, or action 2 occurs after action 1, right? So that's fairly simple. So we thought, okay, so if we're going to specify this, we want to make sure you capture the entire action. And if you're just using the name, I'm going to put it in quotes so I don't get confused when I'm parsing this. And then I'm going to say action 1 before action 2. So I'm going to leave out the word occurs because that's implied, right? So I think that keeps it simple. And then we put it in brackets so you can kind of ultimately be able to nest these. So we want to be able to do, that's another thing I know we're going to want to be able to do, right? So that's what we're doing there. And of course, you could say action 2 after action 1, and that would be equivalent, and there's nothing wrong with doing that verbally. So again, this is the kind of thing a semantic AI is going to be looking at to determine which do I do? What does that mean? And that those 2 are equivalent will be something you'd have to train your AI to understand. Have I lost anybody yet? I think I lost Mario. Okay. So simple or. So here's what we're suggesting for that. So here now it's an if or action 1, and so again those should be in quotes. I'm sorry, I wasn't quite as precise as I should have been. Equals yes. So in other words, that's going to be the yes branch. Then you're going to execute action 2. So again, I need to add a new word in there to help me go beyond so the conjunction is the if, and then the execute is there to make sure we know what you're supposed to do at that point. So it's to make sure that it's clear you're going to execute action 2. And then if the or action 1 equals no, I'm going to execute action 3, right? So that reads pretty easily, pretty simply. And again, this is why we want computers to help us do this, because of course people don't follow the syntax fully, right? So that should have been with quotes. Does that make sense? Okay, I didn't lose anybody. Similarly, I think I did it here with the 3. I did catch it here. So you see the same idea here. So you're just nesting them, you're just chaining them along. Okay, does that make sense? Okay, simple, clear. It's sort of bunny rabbit English, which is what we want. We're trying to get down to. So it's something the AI can look at and use very effectively. Loop sequencing. Now loops were a little bit more interesting. So here's one where we're using the for as the conjunction verb. And then now we had to use an execute. Now during the loop execution, now again, this shouldn't be actually probably bolded on the word loop there. It's actually just part of that what the name of that particular action is. And then the key is to have a repeat option. So now I know I need to repeat this thought. And then for loop action equal exit, I'm going to end the loop and so go out of the loop. So head to the end. So one of the things that in Innoslate and we actually in LML we're trying to minimize constructs to avoid confusion. One of the things we had to do when we implemented this in Innoslate is we have to put handles for these things. So there's actually a handle right there where the between the end circle and that line, that dog leg that it does there. So that's where you'd have a handle to help you move it around, things like that. So there's some little things you have to do when you actually implement something like this kind of language. Okay, sync sequencing. So this one is kind of interesting. It's action A and action B until action C. So that's an interesting thing there. We think that's the right way to say that. Again, maybe you can think of some other ways, but that almost seems too simple. So anyway, that's what I've come up with so far with that one. Okay. Should grab my water. Okay, so putting it all together, it looks something like this. So here's that same diagram we were looking at earlier. And we are now trying to see how it goes. So you can kind of see how that nesting makes sense. And now I've got my start and end in there as well. So the start has to start the action, and I have to make sure I hit an end. So there's my boundaries, right? So that's that brackets, and then the rest of it there. So I think that's correct. Again, doing it by hand is never the fail-safe way of doing it, but it looks pretty close. So does this make sense to everybody? Is this? I know this is pretty esoteric. But this is how the sausage gets made. Okay. So again, keywords that we have are start, end, of course, before and after, and if, execute, for, repeat, and loop, until. So it's a nice simple set of keywords we end up with. Again, as you're training your AI to understand this and communicate it and connect it to other languages and other things you're trying to do, then this should be a nice, easy set for it to work with. So our next step is to test it with LLMs and see if it can produce an action diagram. Amir's been working on that, has done some preliminary work. It looks like it's feasible. We're starting to get that kind of information back. He's nodding his head, so I'm not saying something that's not right. And then we want to refine the language to include input, outputs, and resources, because they have impact on sequencing, significant impact on sequencing, right? Because you have triggers, you have data elements, right? So different ways we deal with the IOs. Resources can be consumed, they can be produced, and they can be seized. So it has some very interesting ideas that are going to add to this. So it'll be more than just conjunctions when we finish. to work with this, but at least it gives us that good starting point. The other thing we want to do is make sure we have a good JSON expression of these languages, because almost every modern software tool is moving to JSON. Okay, so APIs now are almost going to become well, there are JSON APIs, I guess. You're moving JSON objects back and forth. Okay, but so that's a little different than what we've been doing with REST, and I think that's actually a real improvement in terms of understandability of what's data is being moved back and forth. We definitely want to include this concept of conjunctions in a future release of LML. Not sure what release number that will end up being, but it's going to be down the road because we're still going through this and finding, well, what works and what doesn't, and how can we do that. And of course, it has to be ultimately implemented in software tools. So I will have to convince my developer that, yes, this is a good idea. Instead of the current way we do it, which is behind the scenes, we have a lot of metadata that actually does this. And it's very complex in the back end. In fact, it's so complex. My current lead developer was not the person who developed it originally. And he says, I go in there and I barely want to touch anything. So this actually gives us an opportunity to refactor that or re-architect that diagram, which is something we felt is due, definitely due anyway. So I think that's a good thing. So that's all I had. Any questions, comments, thoughts? Okay, yeah, I bet you do.
Yeah, so I'm in my language era.
Exactly.
So my first question was about the loops.
Mhm.
The exit is, so a trigger would be your inputs and outputs and resources, or one of those. So to exit, or what's the
So again, right now, all that's saying is the decision point called loop action 1 is determining whether to continue or exit. It could be any kind of logic in there to do that. Now, could it be a resource triggering it? Yes. Could it be an input output triggering it even? Yes.
But it could just be iteration.
Yeah, but it could be just an iteration. Pick a number of iterations. Yeah, you want to.
And then, sorry, I had a meeting, but my other question was about the sync.
Oh yeah. Uh-huh.
Do you recall what that was previously? Because I really like I guess it's one comment. The and until, that seems much simpler than I think what the last version of the spec had. Do you recall?
We didn't have it.
Oh, we didn't have it.
Yeah, that's been one of the bit of holes we thought we had. We didn't have the execution logic
Okay.
explicit in the standard.
Okay.
So that's actually the hole we're trying to fill here.
Okay, sorry.
So actually, I'm excited to have you engaged with this because you can help us do that right. I will tell you, I've been doing this in my spare time, which is like I have zero spare time, so, or near zero. So it hasn't put a lot of brain power into it, but it's something that's been hitting. I don't know. We've been talking about this, Warren, for at least probably a decade about doing something with this, and we're finally getting around to doing it. So yeah.
So
Just a. Oh, I'm sorry. I should have been.
And then I have.
there you go. So earlier Steve said that he used Innoslate as a test bed for LML. I appreciate that, but there are some differences between LML and Innoslate. You have to do certain things in Innoslate to make it a tool that they can use and then market, right? Where it's a little bit different. So if you took the LML standard and you were going to make Sarah's model-based systems engineering tool, it doesn't mean your tool is going to have the same functionality.
Nope.
That's simple. So there has to be that secret sauce in there, so they're competitive.
And that's going to be true with any tool situation. That's something I think a lot of people. I haven't been wearing the mic. I'm sorry. Oh my gosh. This is the problem when you're both the moderator and the speaker. So. What's going on with that? Hello? Testing. There we go. Hi. Okay, so, Sarah, go ahead.
Just my last question now. So these are called, and again, I'm sorry, I came out late. So these are what you're calling conjunctions or constructs, or what are?
Yeah, conjunction. So we're using conjunctions as the language element we're trying to represent, because that's the language element of sequencing. And so that's why we picked it. So again, our classes are nouns, our relationships are verbs, our attributes on the classes are adjectives, and our attributes on the relationships are adverbs. So again, a lot of people say, hey, we need a semantic language or semantic ontology. This is the essence of a semantic ontology. I mean, you can't get more semantic than this.
I figured I missed a slide, kind of like
Yeah,
this.
yeah. So it's really something we want to model after real language, because otherwise you don't have a real language. This has been part of the problem I've seen. In fact, is we've had diagramming frameworks, not languages. We've been calling them a language, but they're not really a language. Whereas this is really a language.
Have you played with nested loops?
Not yet. And that will be interesting. But I have to think it should just look like that. You just put whatever that lower level loop is in that same spot where the loop execution was. So
Part of the AI was for nested. So it put a for loop inside of a for loop. Now that's very base level,
Yeah.
almost zero training. But if I can add something on this, when I was doing the evaluation, and just on the technical side of it, modeling is a stochastic process. You model in a dynamic way, but how back end of any program executes that physically is very deterministic.
Mhm.
If you do this action, this code should present on the back end for this display to happen on the HTML CSS. So currently, we don't communicate this action sequence at all to the customer. We have a sequence in our metadata in the back end, but this enables us to communicate with the customer that action A came before action B. Plus, it'll allow, because the semantic is deterministic, all you have to tell AI or just your NLP or just your normal software, all you have to tell it to do is place this entity before this entity, or place this entity in this for loop that has this continued action. So the deterministic part of executing the software is what allows us to do this. Plus, you train an AI model to generate massive diagrams for you. Once you train out of the deterministic data, much easier than me, because currently I have to tell the AI and be like, hey, generate this metadata with this JSON vertices and put these vertices here and there and generate that. It's a lot harder than telling the AI to generate 15, 20 lines of code that provides me my conjunction semantics. It's difference between 300 lines and 20 that executes the same model.
And the other thing that I think is exciting is also it'll help us create better human readable output. So one of the things we did a project for NASA called we created a tool called Sapatra out of a phase 1 STTR. Okay, and by the way, nobody does that, but we did. And so in that though, we've had struggle. We were able to convert the SOP to the behavioral diagram, but coming back has been a bit of a struggle. And so, I mean, we could do a very simple version, but really this will help us make a much better output for the user. So now you'll have a human readable SOP coming out of it that looks really good. So.
Oh, absolutely. Amazing.
Say again, what did you say? I heard even.
He asked if I refined the prompt and the testing that I did.
Yeah.
I actually showed you the results. For the basic stuff, it did pretty good. It messed up on the until sync. And it also messed up when sequences were branches. So the AI's vision wasn't seeing a close of a parallel. So you know how, can you show parallels?
Yeah.
A parallel happens, events at once, and then it joins back in. It wasn't recognizing that parallel C is ending and then executing a next model. So it wasn't putting it before, it was just compounding it under each other's net. So I was like, hey, this is the problem. When you see the closing of a parallel, that means your action ended, you're executing a brand new action post. So that kind of refining had to happen, and that's expected because the vision is only
Yes.
so smart to see. Now, in the code generation, it was almost very deterministic and correct because it just followed a format.
So by the way, when I originally drew this diagram, we actually had a line to the action C from the start, because in fact, in reality, you have to start up action C before action A and B finish. Otherwise, it can't do the job of the synchronization or the timeout. So so that's why originally it had a line in there. We took the line out because people thought it was confusing.
But frankly, to me, it's more accurate. And so,
Do you know how you know?
I can do a bunch of ones, but you guys have like a better version. I do it's shaping up to be a better version, right? But all the features I would ask is to be kind of like the gap I've been using.
Yeah, no, I've done a lot of experimentation with AUL.
you okay?
They have Eraser GPT in there. But, is Andy doing this remote?
Yes,
Yes.
you should be joining the Zoom.
Okay, so he should do all that stuff.
Yeah, another.
I haven't seen him.
Okay, we'll make sure it's there. Okay, thanks. Everybody, I gotta go ahead and get ready for the next one, speaker. Thank you. So I did have to use this, like, because
Was it messed up?
yes, it didn't come out with it. I was a little surprised.
Oh, I know what it was. Was the end?
Oh, yeah, that was what it was. Okay, who's up next here? We've got Dr. Vaneman. Dr. Vaneman.
As Taylor and Charlie, you get to do the extra 5 minutes. So.
Here you go.
I get extra 5 minutes.
You get extra 5 minutes, yeah.
Like that,
All set.
like that.
Charlie here, and you're all set there. You've been doing this, right? I didn't know if we've done that one.
Where's the camera?
You are between us and lunch. I just do want to warn you about that.
I've been warned by that about that.
Oh, have you already?
Yes. Yes, my co-author has warned me of that. He said, keep it short. I have to do my bio, I think.
I'm gonna do it quick for you. Why not? It's a short one. There's the.
Yeah, but I'm gonna pull it up here.
Oh, okay. Well, I still like to do it.
Okay, whatever. It's up to you, man. Just trying to help you out and give me another couple of seconds.
Good. One more second.
AI features that are like that is a solution to have.
No, it's all part of it. Oh, yeah. No, we don't ever do that. Oh, no. What you see is what you get.
Don't go get yourself bought out.
We don't do plugins. We don't do that stuff at all. I hate it.
What you see is what you get.
Okay, so I have 12 o'clock. So our last paper for lunch is Dr. Warren Vaneman. He has over 37 years of leadership and systems engineering experience from positions within the intelligence community and Department of Defense, and is currently a professor of practice at in the systems engineering department at the Naval Postgraduate School. He's a retired Navy Reserve captain who has a BS from the State University of New York Maritime College, an MS and PhD in industrial systems engineering from Virginia Tech,
and I'm happy to call him my friend over many years now. I won't say how many.
Many years, many years. So thank you, Steve. So thanks for attending my presentation. So some of you may say, hey, how come you didn't change this generic thing? Steve said I was industrial and system engineer. So this is part of my industrial engineering roots. So I'm like, I kind of like that. I'm not sure why we did that, but my son said, hey, you should change it. Like, why? I'm an industrial engineer. So on behalf of myself and my son, Wyatt Vaneman, my co-author, I should say my co-author. You know, we're excited to be able to talk to you about some preliminary work that we've been doing. So as a systems engineer, I'm interested in bringing data together, right? From a model-based systems engineering perspective. You've been hearing me talk about data-driven systems engineering, this virtual representation of the system. I kind of have a passion for that, I guess. You know, Wyatt, on the other hand, he brings along a lot of database knowledge, and he does a lot of cybersecurity stuff. So we said, what happened? You know, what about this authoritative source of truth? So in the definition yesterday, and I'll show the definition again in a little bit. For data-driven systems engineering, we're talking about this data, right? We're talking about this virtual representation of this system. So what do I mean by that? I kind of alluded to this earlier, but say this is my system, right? And Jerry's not here, so I can go through this example because Jerry always calls me on it, right? But he likes it, but he just says I overuse it, right? So I have this cube here, right? This microphone. And if I want to look at this, I could say, hey, I could look at it and I could say, this is the physical thing. I could describe it physically. I could come up with a model that describes it physically. That's one way of looking at this. I could also say, what does this cube do? So I may be looking at it this way now. Maybe I'm looking at it this way now, right? So I just turn it a little bit, and now I say, what does it do? And that's where my operations stuff comes in, my functional, my operation stuff. I could say, how much does this thing cost? And I could look at it on how much it costs, or what are the risks, as Amir was talking about earlier, right? Or what are the requirements? I can look at it from multiple dimensions. This data is from multiple dimensions. I can look at it from the top down and see the hierarchy from the top down. I can look at it from the bottom up, or I can see the model from the bottom up. So what I'd like to say, when I tell people about this, from a virtual representation of the system, I want to climb inside this, and I want to explore it from different perspectives. And that's what we're trying to do. Okay, that's what I believe we're trying to do in data-driven systems engineering. But how do we do that, right? So one of the ways we have to do that is, since we have these multiple perspectives, we have different tools, different models that are going to present these different parts. One tool, one model is not going to do everything, right? So we need to bring in these different parts. And if you look at the DoD Digital Engineering Strategy document, which is a bit dated right now, they talk about combining this data, but having the data reside in its current location, with its current tool, in its current format. And somehow, in goal number 2, we're going to combine all these things, and we're going to have it in this authoritative source of truth. Now, if I went around, as I go around, and I talk about the authoritative source of truth, you know what people do when I mention authoritative source of truth? Their heads start nodding up and down, right? North and south. Because everybody knows what the authoritative source of truth is, right? So we start asking questions. Hey, what's this authoritative source of truth that we're really thinking about? And when we start asking that question, when Wyatt started asking me that question, because hey, I'm gonna help you bring it together, but what are we really talking about? I didn't know, right? So we had to look at that. So again, the data-driven systems engineering, it's this modeling approach that helps us to develop the system data, to exchange the system data. I know there's been some talk about different diagrams and stuff like that. I personally, as an engineer, like to create the diagrams and have this virtual representation build in the background. I did this a lot with Innoslate. I could create an action diagram, as Steve was just showing in his last presentation. And it starts building this virtual representation. I can make those relationships in Innoslate, and based on the relationships within the lifecycle modeling language. And I always tell the students that we're going to create this system, or this system in this model, or this model of the system. I only want to see each entity just one time. And that's a huge grading point. I go into the database, I'm like, why do I see this more than one time? Because if I see it more than one time, which is the real one, right? Which is the real one? So now I pass entity 1 and entity 2 downstream, and what happens? They're not in agreement, and somebody downstream, some developer is going to say, hey, these things don't agree, and I can help you fix it, but it's going to cost you, right? That's the way it works. So again, we think the data-driven system engineering, we think we have to go there because, model-based system engineering, Steve and I are both kind of afraid about the future of model-based system engineering and what that is going to do to the discipline of systems engineering. So I mentioned authoritative source of truth. So this authoritative source of truth is a virtual repository. What's that mean? That means the data resides other places, right? But we bring it together to solve a problem, to solve a system problem. Is it permanent? I don't know. I guess it could be, but we're not talking about everybody give me your data. We're going to have this huge representation. We're talking about, hey, let's talk about the system. Let's bring in the system data that we need to make a decision, because we should be driving decisions, right? So this is a central repository. To have this central repository, we have to have some rules, right? We have to have some governance, and that's where the ontology comes in, right? And we'll talk about that in a few moments. And we want the authoritative source of truth. What's the first word? Authoritative. So we have to have a way to say, hey, is this the most trusted data? What if the data today is the most current data, but tomorrow or next week or next month, more other data comes along that's more authoritative? How do we know that? How do we incorporate that new data and get rid of the data that we once thought was authoritative? And how do we do this traceability? So I'm a big guy on traceability. If I'm going to make a decision over here, how do I causally trace that through my system to figure out what the impacts are going to be throughout? So I have to have that traceability, right? And I have to have that traceability. And okay, so from a document-based system engineering perspective, from the way that model-based system engineering seems to be practiced a lot of places, right, where we don't have that traceability. Even in model-based system engineering, if it's not practiced as it should be, as it could be in all the tools, which it's often not, then we don't have that traceability. Heck, I have colleagues who use Innoslate as a drilling tool, right? Okay, so where's that relationship between? Where's the impact? If I do something over here, where's the impact going to be over here? I know in class, students have to suffer through this, because if I tell my mom to do an action diagram and an IDEF0 diagram of both actions, and becomes a problem, I'm like, just think of it as math, and you're solving simultaneous equations, right? So you have to kind of work the two in conjunction, right? So that's what we do. So we started looking at this, and we said, you know what? I'm not sure I understand this, right? And why didn't I talk about it? And said, we have to understand it. So what I did, I said, I'm going to start looking at things from a set theory perspective. I'm like, what the heck are you doing? Okay, it's right before lunch, and you're going to talk to me about set theory, right? So I'm not here to talk to you about set theory, and I'm glad this isn't right after lunch, right? But what does the set theory do? Set theory provides this mathematical foundation, right? So the way a lot of model-based system engineering today is, the way document-based system engineering is, we don't really use a mathematical or theoretical foundation. This mathematical foundation helps us to bring these entities and has these relationships and helps form this structure. It also provides rules for joining, right? Rules to become a member of this piece. And it also tells us how to bring this stuff together, how to integrate it. So I think the most important part for me as a former modeling and simulation guy is the verification and validation. In set theory, we have the different mathematical principles, and we're able to apply those mathematical principles to actually do verification of the model. Today, if you look at the modeling and simulation crowd, they kind of joke on us a little bit because, hey, you systems engineer guys are providing or you are developing these models, but how are they verified? Think that's about it, right? So this gives us a way to do that. And plus, if you look at this, it's kind of interesting because set theory is really the math of combining these different data sets. And what are we trying to do with an authoritative source of truth? We're trying to combine these different data sets. So that's one of the things that we thought about. So there's been some discussion on ontology today. I mean, a few years ago, I don't know, maybe it's more than a few years ago, I had a discussion on ontology. And if you recall, Steve, it was an NDIA Systems Engineering Conference, and there's this large room. It was well attended that day. I'm standing along the wall, and the person said, "Stop the presentation," when she saw me standing there. And you know who I'm talking about, Steve. And she says, "Warren, I saw your presentation on ontology, and I don't like that word. Change it." So I never changed the word. I mean, at the time, the president of NCOSI came to me and who I know is a friend. He's a friend of Steve's. And he said, "You know, Warren, maybe you want to call it meta model and not ontology." I'm like, I'm not changing. So now what do we have? Come here and there's all these discussions on ontology. You go around DoD and there's all these discussions on ontology. So when we talk about this ontology, we're talking about, if it was set theory, this would be my universal set. This would be my possible combinations. You say, wow, that could be a lot. That could be a lot. So what we have done, and we have used the lifecycle modeling language, and we have actually, this is probably the most mature part of the work, right? We have looked at this, and we have an ontology. We use the lifecycle modeling language. We work with Marine Corps System Plan. We developed a lifecycle modeling language. We took the 20 different entities in the lifecycle modeling language, and I don't claim that ontology is the lifecycle modeling language, by the way, Kevin. I think we just did our research and we did our literature review, and that's what we found. And so we took these 20 entities, and I'm like, wow, we're going to work with Marine Corps on this. We're going to have to expand it probably to 30 entities. Much to my surprise, we shrunk it to 15. And what we were able to do, we were able to take these entities and we were able to further divide these entities into sub-entities, right? So for example, in Innoslate, what do you have? You have an action. What the heck's an action? It could be an operational activity. It could be a function. It could be a capability, right? It could be I guess it could be a task, right? So we could go down the list. So what we were able to do, and we tested this pretty extensively with the ontology we built, and we were able to put everything into those 15 categories. We're giving you 5 more here, so that's great. So you have to have an entities. There has to be relationships. The relationship is where the complexity is. The model complexity can be generated from in lifecycle modeling language. So, and then we have these different attributes. So what we did we took these entities and relationships and we started looking at these and we said, how are we going to manage these? And Sarah, you said it yesterday, you put everything in ProGL. We started putting things in ProGL. We've done some work. I've done some work with some thesis students on this. And what we're able to do, we were able to put this stuff into ProGL. And this, because we were able to model this whole thing, we now have the universal set that we can use. Anything that we have other than that, right? Anything we build within that is a subset. We're not going to use all these because why? We have 20 different entities and we have all these things and all these entities have a one-to-n relationship, right? So at the end, I don't have 20 square possible combinations. I have 20 factorial combinations. Right, and there's 20 factor, it comes out to like 10 to the 18 possible combinations. Give or take, it's really not 10 to the 18, it's actually a little bit less because you have like a blank cell right in there, but there's a few and far between. So it's a good estimate. So we said, okay, so what are we trying to do? So we're trying to take we have these different models and we have this different data within these models. See these entities here and you have these different data and we're trying to just combine these things, right? Now I know there's different approaches. This is the way we are interpreting it. I know there's several different thoughts on this. You could have pointers, you could have I think Kevin and a couple others that I were talking about last night. They have an approach. I think your approach kind of is a little bit different than mine, but not significantly different. So in this case, we have these different models, and for our perspective, we said we have this authoritative source of truth where we're going to build this virtual representation of the system, right? And what did we do? We look at these and we said, okay, how are we going to combine these things? So in this case, this entity X right here is common throughout. So here you go. Entity X1, X2, and X3 are assumed to be equal, right? They're assumed to be equal. And if they're equal, then we're able to combine those and we're able to say, okay, give me all the stuff in all the relevant stuff in one set, another set, and boom, we have this authoritative source of truth. Well, this could work if you have a common language and a common tool, right? But when you look at this, it really is more complex than meets the eye. And when we started getting into the set theory on this, we're like, well, you get to a certain point and a proof, right? You get down to that point, you're like, well, I didn't solve the problem. I'm not a QED yet. I have to move further down, right? And so what we decide that even though these EXs, E sub X's appear to be the same entity, they're really not. And they're really not because of a lot of different factors. So we view this as the challenge of the ASOT, right? We view this as a challenge of the ASOT. We're not just looking at data entities, relationships, and attributes. We're looking at data format, data fidelity. We're looking at the different modeling languages and data consistency and data. And I couldn't leave data security out, but data security, because if I have multiple data sets, okay, hopefully they're all going to be secure, but are they all secure when they're combined? And we don't believe the answer is yes. So we have all that. So instead of just having this view of the different data sets, we have this view. So this view all comes together. We have to look at all these different things. And when we start looking at this, and we say that the data is no longer EX and EX1, EX2, and EX3 aren't necessarily equal anymore. We're saying they're approximately equal. They're like things, but there's some differences, and those differences are in maybe the different relationships, maybe the modeling language that's more likely, the format, the fidelity could come into it, the data consistency, and the security. So when you're doing this, and you're trying to create this virtual representation of the system, and you're trying to bring this data from all over these places. This, we think, becomes this combinatorial complexity problem. And if the data is going to change over time, then we're going to have this dynamic, we're going to also have a dynamic complexity, have a dynamic complexity problem. So when we look at this, the space for this, solution space for this can be huge, So how do we address that? So we don't really have a good answer yet. We have an answer that we tried, right? Or that we have been trying. And we were able to combine these different large data sets. And, we already have this governance tool model, and a governance model can be used by ProGL. Wyatt did generate some Python code to use SQL, and then Wyatt also has a minor in computer game design. He's like, well, what if we use C#? So he's been playing with that a little bit in his free time, right? But here we have these, we could do this, and we have these, if we have these large data sets, right, from these different sources, it's going to be difficult to maintain with just a human in the loop. We believe that when you bring all these different factors together, they have to be brought together using machine learning and AI, because we have different formats, we have different languages, and even though these things look alike, we have to have something that says these things are really alike. So we also said, what about the accuracy? So the accuracy stuff actually comes free if you build this ontology right. It's free because it's built into ProGL. ProGL is, a lot of it's based on set theory, right? So now I have all these different principles that I can use, and I can now do some verification of my model. That's something I was unable to do before. So in summary, I'm glad you gave me that extra 5 minutes, Steve. So we believe that the ASOT is fundamental to DDSE. We realize that the ASOT is a term that everybody seems to use, right? But I think we're often talking about different things. And I don't know, I'm all about definitions and defining things, because von Clausewitz said in his book in 1805, he said that it really definitions matter because we have to be on the same platform, right? And we're just trying to say, hey, what does this mean to us, right? And we're probably not on the same platform right now with you, but that's all right. We may be close, right, Kevin? We may be close. If you think about the way people talk about data integration and the authoritative source of truth, this miracle occurs. And boom, I'm able to take Innoslate data, and I'm able to take Spark's enterprise architecture data, and I'm able to take extend-sim data, and boom, this miracle is going to occur, right? It's magic, right? So it's not, we believe that's a combinatorial complexity problem and possibly a dynamic complexity problem. Okay, so I wasn't much into set. When we started this, I'm like, I'm going to prove this in set theory. Like, no, I'm going to use insights from set theory to help me gain some insights, hopefully. And it's worked out so far. But we strongly believe that if we're going to do something like an authoritative source of truth, to represent that virtual system, you really have to move to machine learning and AI. And there has to be this governance, right? And Kevin, I gave you credit right there. There's a quote, right, from your book. I stole it from Kevin's book, but I did properly give him attribution for it. So any questions?
You gotta moderate yourself, okay, good.
Oh, my bad, Ed brought it. Oh, sounds like the Three Stooges are called.
I know.
So, sorry, that's my phone.
I like the thing about the consistency and all of that, I totally agree with you. So here's something to think about, right? Because you talked about the idea of having, essentially multiple instances of something, and you're like, which one's the real one? And it could be because there are variations in it or differences in time, but think about this for a second, because it's a concept that I talked about in the book, so maybe you might recall it. If you're talking about, the authoritative source of truth, like if you think about sort of in the context of the bionic enterprise, it's that bionic brain.
Yep.
All these agents tapping into that data and that knowledge to do all the different things for everybody in the organization. Like if you remember, I talked about the idea yesterday of, like the brain knows about all the meetings, all the conversations, all of the different projects. It's all there in that authoritative source of collaborative truth, so that it can help make the connections that people aren't even aware that exist,
Yep.
right?
Yep.
And discover patterns and go, hey, so-and-so, did you know about this team over here, right? But think about this. One of the things that you run into is that what you're describing is part of how to build that centralized brain, whatever the knowledge and the information is. But what happens when you need to have that knowledge and that information at the edge, whatever the edge of your enterprise is? What happens is that some of it gets replicated over here, some of it gets replicated there, some of it's created over here, and yet it needs to be integrated and synced with that, if you want to call it a centralized copy. So you've got centralization, you've got decentralization. And wow, so now, and how many different points of decentralization might you have where you've got to now maintain that consistency, because you actually could look at it as multiple sources of the truth, or it's a federated authoritative source of truth. It's not just that one instance of, the big ball of yarn like you're showing. And so one of the techniques that you could use for maintaining the consistency and the replication will be the blockchain approach. Because think about why was blockchain created? It was to maintain consistency in transactions virtually instantaneously, right? So that your system has, or your database has the knowledge of a certain transaction, and I get that same knowledge like instantaneously, and it's got that reliability, right? Assured, it's kind of the assured aspect of the transaction. It's not just occurring in one place and now you have this latency factor. So you kind of have to look at something like a blockchain to realize that you're going to have pieces of your source of truth. It's all collectively in the virtual sense part of that, but from an IT perspective, they can be distributed, and the way to kind of glue them together could be a blockchain type approach. If that makes any sense.
That makes a lot of sense. I appreciate that. We'll look into that because we have not considered that yet.
Amir, blockchain.
Wow. I see those.
How do you, what if you have two entities asserting that they're the single source of truth? How do you handle conflicts with contending claimants to be the single source of truth?
So it's either you have certain rules that are established, right, presumably within your AI to help you with that, or you have to have human in the loop, right?
We have time for one more quick question, and then it's lunch, and you can buttonhole.
And now Sarah's going to beat me up.
No, I just have one question. I was just curious, you mentioned meta models. What's your take on creating a modeling language meta model and the difference with those in ontology? Do you have any? If you don't think it's fine.
I don't know, you might, so this approach is showing how data could come together. But once that data is together, it's not saying how to do analysis on it. It's not saying how to portray it. So I could have data from all these different sources, and I'm able to combine the data and have this spiritual representation, great. But the question really becomes, how do I view it, right? Do I have to have a common language, such as, say, Innoslate, for example? I'm not sure Innoslate could do it, but whatever. Of course you could do it, right, Steve? Because he's the vendor. Because he's a vendor, he can do everything, right? But how do we do that? So there probably has to be some sort of language for that.
Like UML and SSML, they preach the meta model on basically a model of model, right?
Yeah, I guess.
Yeah, I'm not sure. I know that may be a difference without a distinction.
Yeah, and I don't know. When it comes to SysML, there's still lots of unanswered. There's still questions I keep asking, but I don't get answers.
Okay, thank you. I was just.
No, I appreciate that.
Okay, thank you.
Actually,
Good job. Session. Lunch, everybody, lunch. We'll be back at 1:30. Anybody online?